Okay, for homework 9 to get you ready for Friday's exam, I'm going to have both classes write all of this work. You do not need to write the words to these word problems, but make sure if there's any math, write down all the numbers, all the work, and then write the 5 words that let me know you listened to this from beginning to end. My honors classes post your work. For my regular classes, feel free to turn it in, or anybody feel free to come in at lunch or break to turn it in. So here we go. These first ones are just having you identify parts of the equation. Remember, we're looking at equations in slope-intercept form, or in this function notation, d times x plus the function at the 0 term, or that's the same as y equals mx plus b, where m is your slope and b is your y-intercept. These are equivalent. They're the same. So this first one, the 500 is not attached to the x. If it's not attached to the x and it's just a free number there, that is at the 0 term. If this was zeroed out and there was nothing here, you would still owe 500. So the 0 term, the y-intercept, the f0 term, or the one-time deposit, that's what that is, how much you're spending before you start paying rent. That 1400 is the common difference between each month, is the rate of change, is the slope, is the number that goes in front of x in both equations. So again, that 1400 is monthly rent, or how much you're paying each month. That's what that monthly rent is. Again, that is the number in front of x. The number in front of the variable is always your rate of change. The number by itself is always the y-intercept, or the starting point. Alright, this next one, they flip it around on you. It's not always the order. Again, the number by itself, that is the 0 term. For this problem, before any time began, there were 800 gallons in the pool. They call it the initial number of gallons, or the y-intercept, or before time has begun and you started draining, you still have 800 gallons in there. Alright, the negative 3.5, that is your d term, or your slope, or your rate of change. This is arithmetic, there's no exponents. This represents how many gallons are draining each minute. 3.5 gallons every minute this pool is going down. So how many gallons are draining each minute? Or the rate of change, it's a constant rate of change, will be a straight line going negative direction. This is a positive rate of change, will be a straight line going up from left to right. The first word is practice. Practice. Alright, these interest problems, I would like you to realize that if you're borrowing $400, that is how much you owe right away. That is your 0 term. So before you start earning interest of the money you got to pay, this is $400 how much you owe right away. So to find the rate of change, I'm going to take two values and compare them. I'm going to take this 420 and divide it by the number before it, 400. So if I divide the previous number by the one before it, I'll get 1.05. If I divide 441 by that 420, I'll get that same 1.05. That is my common ratio. So for each of these, I'm timesing by 1.05. Make sure you're showing all this work, writing all the words that I'm saying. So timesing by 1.5, timesing by 1.5. So for this problem, I'm going to write both forms. On the test, you pick one to write. So I'm going to write the 0 term one. So that's 400. These rate problems always geometric, times the common ratio 1.5 raised to the x power if I'm using the 0 term. Nothing fancy with the x. Paying the price with the 0 term, but easy with the x. The next one, going over to the first term, 420 times 1.5, and then a little bit more complicated to the x minus 1 power. And again, for this problem, you're just giving me one of those, and that's it. You're not plugging in like this next one. This next one here, again, the equation we're using is f of x equals the f of 0 term. For this one would be 300 times the rate changed to a decimal. Remember, this is 1.04, not 0.04, not 0.4. 300 for the rate of change, or for the 0 term. 4% written as 1.04. If that was 5%, 1.405. 6%, 1.06. So I put that in the common ratio spot, and I'm going to actually use this one to evaluate it for 6. So first I'm going to write the equation. So the equation is f of x equals that 300 times 1.04, not 0.4, not 0.04, 1.04 raised to the x power. And again, that's the equation I'm going to use. I'm going to now, after I write the equation with the x's in it, now I'm going to plug in the numbers into the x spot. I'm going to use it now. So the equation being used, I'm evaluating this function at the 6th term. That's what that means. I'm going to leave that 300 alone. The 1.04 leave alone. I'm going to put a 6 in that exponent spot. I want you to type all these numbers in your calculator right away. I want you to type in the 300 times the 1.04, raise that using the little caret button to the 6th power, hit equal, and I'll show you how to round. So that answer gives me, and since we're rounding to money, we're going to round to 2 decimal places. So as I use my calculator to get that, that is $379, $595.7. Just do a few. We're rounding to the 2nd decimal place. The number to the right of it is my indicator number. If this is 5 or more, this bumps up 1 and would make this 60. If this is 4 or less, I would leave this alone at 59 cents. 5 or more, this rounds up to 60 cents. Don't round this up more. But again, this rounded up gives me $379 after 6 years at this rate, and 60 cents. There's my little dollar symbol right there. The second word is. Let's keep going. Next problem, the ones we looked at today. This one is geometric. Again, if you wanted to compare this number to the first one and use your calculator reducing feature, that ABC button, which I'll help you, that will reduce down to its fraction form, the one I want you to use. That reduces down to 1/3. Again, I don't really want decimals here. I'll show you the calculator on your button, or the button on your calculator, to reduce this down. But that is my common ratio, timesing by 1/3, timesing by 1/3, timesing by 1/3. Going to the right, multiplying by 1/3, multiplying 1/3. The first term here, which is indicated here, first term is 486. Just know, even if this wasn't telling you the first term was 486, we assume if we just give you numbers, that first term is always the first one. So again, if I tell you the first term is 486, great. First term, second term, third term, go back to the 0. If I didn't tell you this, assume that that first number is the first term. Never the 0 term, only if we tell you. Alright, so for this problem, going back to the 0 term, the opposite of timesing by 1/3 is timesing by 3. So again, I'm multiplying by 3. I'm not sure why I wrote 1/3 right there. So if you could erase this on your paper and show that as times 3, just the whole number 3. I'm not sure why I wrote that, but multiplying by 3 to the left. 486 times 3 gives me 1458. Again, change this to times 3. That was a bad mistake here. Didn't mean to show that. This is geometric. I am writing recursive form. F of x equals f of x minus 1 times 1/3, the number going to the right, not timesing by 3, the number going to the left. My explicit function, I could either use the 0 term, so 1458 times 1/3 to the x power, or I could shift over to the first term and use f of x equals 486 times 1/3 to the x minus 1 power. I'm going to use that second one there. Got a little smaller of a number. Now I'm going to evaluate this for the 10th term. I'm going to do my work over here where I have more space. So this function evaluating at 10 equals 486. Plug in that x in for 10 right there. So I get 486 times 1/3. Put my 10 right here in the exponent spot. So the 10 minus 1 power gives me 486 times 1/3, the whole fraction 1/3, raised to the 9th power. And again, that means I'm multiplying 9 of those 1/3. 9 of them. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you're multiplying straight across, multiply the 1s, and then you're multiplying 3 of these 9s. So I would suggest using the exponent button, 3 caret 9, 3 raised to the 9 power. Gives me 486 times 1 over, because remember the 1's on top stay 1, but 3 to the 9th is 19,683, so 19,683. Again, I got that by doing 3 raised to the 9th power, knowing that that 1 is going to stay the same on top. For people who don't like fractions, just multiply the two numbers that you get right away to get that 486 over 19683. I can show you how to use the fraction button where you type in 486 and then you hit this A to the BC button. So again, you type in 486, hit the A to the BC button, hit 19683, and it will reduce it down to its lowest form in 2 seconds. That reduces down to 2 over 81. So technically that's what we would like, but I'll give you full credit for both. So make sure on this one, change this to times 3. I don't want to see that as times 1/3. That's timesing 3. The third word is key. Key. All right, let's keep going. Next one is arithmetic. This one here, I am going down in negative quantity here. So if you just want to take 52 minus 67, you'll get the number 15, which means I'm adding 15 to these negative numbers to make it go smaller. Negative 67 plus 15, 15 positives, 15 negatives cancel, leave me excess negatives. Same thing here. This is a arithmetic sequence. I need you to realize that this is the first term again, negative 67, second, third, fourth. The 0 term, subtracting 15, the opposite of adding 15, subtracting. So negative 67 minus 15, it's going to give me negative 82. The recursive function is f of x equals f of x minus 1 plus that common difference number 15. Always the one going from left to right. My two explicit forms. First one, I could either use that 15 times x, and that's coming. So I could write that as 15x plus or minus the y-intercept term, the 0 term. This would be minus 82. Or I could use f of x equals that same 15, but since I'm going to the right, that would be times by x minus 1 in parentheses, plus the first term, which is negative 67. The 10th term, I'm going to use this top one here. So if I evaluate this function at the 10th term, that will equal 15 times 10. Subtract that 82. Gives me 150 minus 82, which shows me at the 10th term, following this pattern, it's going to go down, 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 then start go up, up, up because you keep adding 15. Gives me 68. All right, so this one, the 10th term, is 68. Show this work. Okay, the hardest problem on the test. Here we go. This one, we're writing the equation in slope-intercept form, which is y equals mx plus b. We're going to find the change in these y numbers. Looks like it's going down by 3. Going down by 3 in this problem I just made up. My x numbers are going up by 6, adding by 6, up by 6. Maybe focus on these middle terms. Easy to see going down by 3, up by 6. Maybe a little harder up here. If I take that and try to write it in y equals mx plus b, first thing I want to do is find my slope form first, which is m. So m, or slope, remember, is rise over run, or the change in the y blue numbers divided by the change in the red x numbers, change in y over change in x. So if I put those numbers in, that gives me negative 3 over 6, negative 3 over positive 6 here. So write that as positive 6. And that reduces to negative 1 over 2. So when I'm now going down or up by just single increments instead of these jumps, going down by a half, down is subtracting by a half. Going up is adding a half. I'm going to have you fill in the numbers in this table to try to show what's going on inside here, the numbers that aren't being shown. That negative 1/2 automatically goes in front of x as my slope. On your table, I'm going to have you fill in these values right here. I think we're going to negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Fill in a table just like that. Know that the 4 and 6 are there. The negative 2 and 9, that is there in the table also. I'm just going to show you what's going on between them so we could focus on that 0 term. So know that going down the column by 1s now is going down by a half, going down by a half, minus 1/2 going down, minus 1/2 going down, going up, adding 1/2, adding 1/2, adding 1/2. If I was to fill out this table to see those numbers from 6, adding a half, add a half, add 1/2, add 1/2. From 6 going down, subtract 1/2, subtract. So 6 minus a half, 5.5. 5.5 minus a half, 5. 6 plus a half, 6.5. 6.5 plus a half, 7. 7.5. And then 8. And then 8.5. And of course, that plus a half is that 9 number that matches this. So for my problem, the y-intercept term is 0, 8. I put that 8 right there. That is my equation. This one right here has you distribute and try to find the one that is equivalent. The equation's coming here shortly. But again, on all of these, you're going to distribute that number in front of the variable, in front of the parentheses. Distribute. That gives me 3. 4 times x is 4x. And then way down 4 times negative 1. Remember, distribute 4 times x, 4 times negative 1. That gives me 3 plus 4x minus 4. These two numbers combine to give me negative 1. So this is 4x minus 1. The equation I'm having you compare this to, if I could have you write this down, is going to be f of x equals 4x plus 2. That is the equation. I'm trying to see which one of these is equivalent. This first one is not the same. Same d, but different zero term. Not the same, not equivalent. If I distribute this and get 3x minus 3 when I times 3 times negative 1, that gives me 4 plus 3x minus 3. And again, that combines to give me 3x plus 1. Bad d number and bad y-intercept. Both these things are bad. This one, negative 4 times x, negative 4 times negative 1, the 5 stays. This becomes negative 4x plus 4. Already I could see negative 4x different than this d. That's not equivalent. 5 plus 4 are 9. This last one here works because 4 times x and 4 times negative 1 gives me 6 still. Leave that 6 alone. 4 times x is 4x. 4 times negative 1 is negative 4. These two numbers do combine to give you positive 2. It gives me the same 4x. Since that distributes and simplifies the same, these are equivalent. This equation here at the bottom, even though it looks different, they are equivalent. And on that problem on the test, only one of them is going to work. All right, last page. This one, I give you the first term 3. So you know this first term is going to be 3. It's given to you. I'm telling you what you're timesing that 3 by each time to find these next 4 terms. 4 of them. So if I take that 3 times 5, that's going to give me the first number. Take that times 5, take that number times 5, and then one more times 5 to fill that out. So 3 times 5 is 15. 15 times 5 is 75. 75 times 5 is 375, and then 375 times 5 more gives me 1,875. So this is the first term. The next 4 terms, the second, third, fourth, and fifth. First term here, here's the second term, third term, fourth term, fifth term. Next 4 terms. Don't stop at 375. That's just the next 3 terms, next 4 terms. Alright, this problem here wants you to identify if it's linear, arithmetic, straight line. This first set of numbers is timesing by 3. I know it's geometric. I know it's exponential. The graph is not straight. The second set, adding by 4, adding by 4, adding by 4, adding the same amount each time will give you a straight linear line. This is a arithmetic function, linear function, straight line, adding the same amount each time. This equation would be 4x plus 2. This one is neither linear or arithmetic or exponential. No good. Next one, exponential, means which one is geometric, which one is your timesing one. This top one going down by 2, arithmetic, not geometric. Do not pick that one. That is not exponential. It's not geometric. This one, a little trickier, but I am timesing by 3. 1 times 3 is 3, times 3 is 9, times 3 is 27. That is geometric. That is exponential. That's the one I'm looking for. That will give me a graph curving up. That is the one right there. This next one looks like it's going up by 2's, which of course makes it linear, makes it arithmetic, but this one wants the exponential geometric one, so that one's no good. The fourth word is 4. 4. Okay, this problem wants you to jump ahead to the 12th term. It's telling you that the first term is 2. Even if that wasn't there, I would want you to know that that first term is 2. First term, second, third, fourth. I want you to see that I'm adding by 5 on these. Adding by 5, plus 5, plus 5. If I go to the left, subtracting 5, subtracting 5. So 2 minus 5 gives me negative 3. If I wrote the equation, I'm going to do both. I could either use f of x equals 5, the adding number, times x, minus the f of 0 term, or the y-intercept, minus 3. Or I could use the first term, f of x equals that same 5, but times x minus 1, plus the first term, which is 2. I'm going to plug it into both to show you. So if I evaluate this for the 12th term, now I'm using it. Plug in 12 here to show what I'm plugging in. 12 here to do the actual math. Minus 3 gives me 60 minus 3, or the 12th term is 57. I could also plug in 12 here and show you how I get the same answer. The function at 12 using this first term one, same 5. Plug 12 right here, minus 1. This gives me 5 times 11, which is 55, plus 2, which gives me the 12th term is 57. One more. Alright, this one, again, no terms listed. First term, second term, third term, fourth term. I want you to go back to the 0 term. So for this one, timesing by 2 makes it geometric. Dividing by 2 or timesing by 1/2 going to the left, which would make that 5. The two forms I'm looking at here, and I'll show you how they're trying to trick you. The first one is you could get it from the 0 term times r raised to the x power, or I could use f of x equals the first term f of 1 times r to the x minus 1 power. F of 0 is 5, f of 1 is 10. This first problem is trying to show you that you put the first term there, 10. But if you use this one, using that first term 10, you would need that times 2 to the x minus 1 power. They don't do that. This is 10, the first term, times the common ratio just to the plain x power. And because that's not true, that's not the same, that is a bad choice. The second one has the first term, f of 0, and it has the r number 2 raised just to the x power. That is exactly what we want. That one is golden. That one in the middle is the answer. The bottom one is trying to trick you into thinking use the 0 term, but you could see this exponent stuff is off. You wouldn't want to use x minus 1 with that one. So that bottom one is no good with that 5 first term and that x minus 1 stuff instead of just plain old x. Okay, hopefully you have this work. And now the 5th word, which is sequences. Sequences. Good luck. See you tomorrow.